on Tuesday. Okay.
Yes, yeah.
Um,
But
and I actually have been thinking that the with the current architecture of Vast,
yeah,
adding that kind of layer externally will probably also be helpful to to sort of gain additional understanding, in terms of
yes,
adaptability,
yeah,
because spatial pops up. That is one, I think, one concept.
mhm,
And Vang and its related neighbor discovery, that is something that's another layer.
yes, yeah.
So yeah, so I'm thinking that, yeah, the separation would be a good thing. Yeah, that's basically.
Okay, cool.
Yeah. All right. So Victory, are you online now?
Yes, I am. I am. Can
All
you
right.
hear me?
Okay. Great. All right.
Yes,
So would you like to
Sorry.
start and maybe share with us your updates? Okay,
Yes.
we're looking forward to
So
it very much. All
sorry
right, go
about
ahead. Go ahead.
Tuesday again. I wasn't close to the internet. I mean, the internet I had that was horrible. I was going to send a recording as well. I don't know how it skipped my mind. So sorry about that. But so there's sort of two phases to this. First, you can see my screen, right?
Yes.
yeah,
Oh, okay. Okay. I spoke to her the last time we met, me and Herman. We basically talked about how we should, um, trying to see if I can zoom this, how I should sort of come up with a pseudocode and with sort of some changes to the to the subscription mode. So this is what I sort of came up with. You might recognize this, Professor Herman, the picture. So again, forgive the imaging. I try to draw it as best as I can. And the idea basically is to suggest that the ones in the circle are just nodes subscribers, and the squares are publishers. Now, so basically here it's subscriber only knows its neighbors. This is just a generic word now, but the data structure basically, the only thing that sort of changed here was the message. I just took that out temporarily. It's also in the publisher, but I just highlighted that as red. But there's the ID of each node, the position, the IP address, and the subscription or the subscription type of the subscriber. Now, when the subscriber wants to subscribe to a channel, it sort of starts with power on, and yeah, power on, just basically like a start. Then create the identity array. So the ID array basically is to show what the ID is. So when you switch on a node, it automatically sort of starts with an ID, the position, the IP address, and the port, and then the channel subscription. Now the third part is now to when you come into an area or maybe a spatial region, you want to find the network, or should I say the relevant network, and try to connect with the IP address. That's where the handshake process sort of is implemented. And then you sort of connect to the server. After you're in the network, the server is, I believe, this is sort of predefined in the node, in the subscriber node. You're looking for a certain server. And 5, send identity signal to server to subscribe. So the idea is you want to send what your subscription is, or what channel you want to subscribe to. And then if subscription was successful, there's like 3 phases to that. We want to wait for success message. You want to receive, so whatever messages were sort of on the, maybe say it was a system that existed previously and there were messages that were there previously, you want to sort of send everything. Again, I should probably highlight this in red because this will probably happen on the application layer, and then also stand by for new messages. And if connection is unsuccessful, you want to time out and go back to step one. Now, again, this error, it can be different kinds of error. For example, I set it up in the publisher process that if it's sometimes the server does not have the relevant subscription, or it's not the right channel to subscribe to. So in that case, the error can be different. And I think in that case, I said irrelevant or not relevant sub, something like that. Now, so there's something similar with publisher, but I think publisher has more data types. You look at, it has the ID, it has the position, the address as well. So now there's a sub list. I think this is a new one. So the idea is each publisher has its own preset, or should I say predefined subscription or channels. Now that's the channels, it's the channels it's going to be publishing messages to. Then the AOI radius, basically it's region, or how many nodes it can connect to in that what's the word, in that region. Let me use region, yeah. And then the channel list. Now this is supposed to be for the external channels. Let me see if I can highlight that. This is for sorry. So maybe so this is a list to sort of save the nodes that are subscribed to its channel. So it basically has like an array or maybe a matrix. I'm not really sure which direction to go with that yet, but it has like a list. The idea is it has a list of all the nodes subscribed with this information. So it has the ID, the position, the address, and channel stored somewhere. And then the process flow is simple. You want to initialize, or should I say, establish communication and connection around nodes around this region. So the idea is you're basically just setting up the server, switching it on, and and also to create the data structure or table for the node information. So again, this is where how the data will be stored. I'm still not sure if I should go with arrays or matrices, but I think that's a conversation for another day. Also, you're waiting for requests. So now if a sub request is made, so first you want to initialize, yeah. Then you want to create the data tables for the pub node and subscriber nodes. So that's the identity of the publisher and also the subscriber. And then the idea is to create it in its table as illustrated here. That's the CH list. And maybe this the CH list and IDTY, which is the identity of its own node. Wait for connection requests. If the sub requests subscription, request subscription, or sorry, that's a double. So if there's a request from a subscriber at this point, first you want to get the identity, and the identity contains the subscription channel or what it wants to subscribe to. So from the CH sub, so identity, as you can see here, there's the CH sub there in the identity, and you want to now compare the CH sub with the channel list. So I want to compare the subscription list with CH sub and see if there's there's a correlation, if the channel exists on that specific publisher. And if it does, that's equal to, maybe I should just add second one, sorry. Then accept subscriber request, send previous data to sub, and send new relevant. So this is the third part, is the part that sort of happens in real time. Again, I'm just going to make that into red because that I think can happen on the application layer. And then otherwise, send error message, which is basically saying, so this error message obviously can be multiple types. It can be timeout error. It can also be that, as a publisher, I don't have the channel you're looking to subscribe to, and then it sends this information back to the subscriber. Now, the second part was I was sort of trying to play around with code, a library I found online, but it's still a bit all over the place. The idea is to create 10 nodes and sort of establish connection with all. But again, this is still I don't know if you can still see these. But the idea is each node is sort of connected to each one. Again, this feels more decentralized rather than centralized, though, because it's almost like there's 10 nodes in total, and each node connects has like 9 connections basically. So every node connects to every node, which is more of a decentralized setup than a centralized. I'm still playing around with the library a little bit, but I think the next step of this is to try a centralized one where there's just one. There's 10 nodes, but there's one centralized that communicates with all the nodes. Yeah. For now, that's all I have. Sorry.
Okay.
So
Great,
the
great. Yeah, Herman, go ahead.
so the Python code you just showed us, that's kind of a simulation of your network at the moment.
Yes. It's what's the word? I found a library that I was playing with. It's not. It doesn't do anything yet. But then the idea is to yeah.
It's a start, in other words,
It's
of
a,
some
yeah.
type of a simulation. Okay, cool.
Yeah.
So if you so just going back to your the thing that you showed previously, yes. So this is the decentralized version of the, or is this a centralized version?
Centralized. Sorry, centralized.
Okay.
Centralized.
So the one thing which was just, if you go down slightly, the one thing which so where would the server, the centralized server, be in this this system over here?
I mean, in the picture.
Yeah.
Oh.
So what you described thus far, it sounded to me like every publisher also has a list of subscriptions.
Okay. So yeah, the idea basically is the C in this case, for example, has the ID of every node in this region, or should I say, every node is connects in this circle. Every subscriber node, it has information to every subscriber node. And when I mean information, it's basically the identity and the subscription. What's the word? Channel.
Okay, all right. One clarifying question is,
Okay.
Victory. Why do the nodes need to know about the IDs and the info about its neighbors? Is it because you want them to communicate directly?
So it's not, the nodes don't have, it's only the publisher that has all the information
Right.
of the
I see. Okay, but okay, this is a key point, which
Okay.
is actually in a PubSub model. Okay, essentially the publish should have no knowledge about the subscribers or the receivers of the message it publishes.
Oh, sorry.
Okay,
So
is that understood? I mean, is that understood?
the publisher should not know.
Exactly.
Or
Exactly. Should not.
That's in a decentralized.
No. That, I mean, that is actually, I mean, if you look at the publish subscribe paradigm, okay, that is the core feature. Okay, it's not to say that the information doesn't exist or the publisher should it once. Okay, you can maybe do a query of the subscriber. However, it's not required for the publisher to know any of the subscribers in order to make a successful delivery, okay, of the published message to the, from the publisher to the subscriber. Is that something that's okay? And I just want to clarify and to make sure. I mean, are you aware of this, or not, or no? You maybe have a different understanding.
No, I do understand that it doesn't need to know. Oh, for example, let me use the illustration. C does not need to know about you to send information to T.
Exactly. Right. That is exactly what I'm saying. Yes.
Yes, that's true.
Okay. So is that, I mean, yeah. Oh, go ahead.
So the only reason why I sort of, again, this setup is under the assumption that the nodes around C are subscribed, have the same subscription. If that makes sense.
Okay, well,
like
it's
I mean, it's not have the same. Sorry, C has the contains the subscription channels for all of the nodes around it.
Okay, so
okay.
Herman,
you want to go ahead?
So I think you're basically saying C is the server for the
Yes.
nodes around it. Ah, okay.
Yes.
So B would actually be the publisher, which sends the message to C saying I want to publish to a specific channel, and then C would then actually compare it to its list of subscriptions and then decide to whom are the other nodes that actually can receive it.
Yes.
So I
Okay.
think
I
what's
think that's where, that's why I'm confused.
Yeah. So actually, one clarifying question. Yes, Herman was asking, is C the publisher, or perhaps someone else like B or J would be the publisher?
So I think where I got it wrong was I considered the publisher to be the same as the server.
Okay.
Right.
You have to understand that server, or in my paper previously, it was a term maybe the matcher. Okay, because matcher may be a better term for the role it plays. The matcher. I mean, doing pub/sub matching, right? So it's a sort of like a matchmaker, right? But publisher, subscribers, and matcher, they are all different roles.
Okay.
See? There are different roles. They can reside on the same physical host or server or machine. That's fine. Okay. However, you have to understand and treat them as separate functions or features.
Okay.
Okay. Because they are different roles. Okay. I mean that. I hope that's clear. And,
that's clear.
Okay.
Yeah.
And if you're, I mean, also just want to clarify. So, are you aware that the publisher does not have to know about the subscriber? I mean, about this characteristic of pub/sub system.
Yes.
Okay, you are aware. Okay. Then that's fine. Okay. So I think maybe yeah, I guess that's as long as you're aware and you can use that to sort of look back at the design or the procedures that you're mentioning to see if it follows that. Okay. Okay. Yeah. But go ahead. Yeah. But I think what you want to say, if C has the knowledge of the subscribers, it's more the the matcher role. Okay. Rather than a publisher role. Okay.
Well, just to confirm, is this like a standard term in pub/sub? What do you call it?
Well, in pub/sub, there's publisher and subscriber, and usually it's done by an intermediary, maybe called a server. Okay. And right, and the matcher term is what I because in a peer-to-peer settings, right, it's not necessarily like one server. Right. Yeah. so that is why we introduced the term matcher to better distinguish between, I mean, to clarify this role.
Yeah, the article on Wikipedia refers to a broker, which
yes. It's the same concept, right? It's the same concept. Yeah, it's called a broker. Yeah, I believe so. Yeah, in the pub/sub, it's called a broker. Yes.
Okay.
It's basically the third party which receives messages and then decides, filters it, and then forwards it to the correct recipient. Yeah, which is basically what the matcher does as well. It's the same concept. Yeah.
Okay. Well, I didn't consider that. I think maybe I'll try to look into that as well. And then I sort of wanted to ask about the decentralized system in the case like this. All right. So in a case like this, okay, now it's my mind is sort of changed now because now there's a matcher. Okay, I guess question one is, are there matchers in the decentralized system as well?
Oh yeah, definitely.
Can that be okay?
Yeah,
because that sort of changes.
The matcher is actually the key mechanism in the decentralized system, because you can think about the node wanting to publish. It's sending it to its closest matcher, or the matcher it's basically going to say, please, in my region, the closest matcher is this. I send my publication to that matcher, and then that matcher will then decide, I need to forward this to, so let's say, what is it over here? P is sending a message to matcher E, and he wants to publish in region where I is, right? So then E would then need to forward it to forward the message so that it eventually reaches matcher I. And then I would say, oh, okay, but the nodes around it, for instance, is subscribed to that region. So it needs to forward that messages there. So I think the other thing, which I just want to, just also a clarifying question, is that, so you understand that you don't have to be in the same physical region in order to subscribe to receive messages from that region.
Yeah.
So M, for instance, could subscribe to receive the any messages being published in that circle around C, for instance.
Okay, yeah.
And all the different nodes could actually have different subscription areas, or even multiple subscription areas. Yeah.
Okay. So let me just follow. I think maybe I would understand better with this question. So this square box itself, just to confirm, that's a network in itself, right? All of these nodes are connected to the same network.
Yes. Yeah. Whether it's wired, whether it's wireless or whether it's using wired internet, yes, they conceptually they can be connected to the same network.
Oh, okay. Well, okay, then it means the circles are sort of irrelevant then, the areas of interest, the AOI.
Yes, well, except if you want them to represent subscription areas or publication areas, but yeah.
Okay.
I mean, so you could have 3 nodes in your system, and each of them have got 10 subscription areas, because they're interested in various things around the area. And then, in total, there are 30 subscriptions going on in the network, and your matchers would be basically just keep track of it. Now, when we're talking about publishers, subscribers, and matchers, that's kind of an abstraction. So in other words, it's a way of describing a certain role that must happen in the network. But if you have a real physical network, then you could have that the node acts as both a subscriber, a publisher, and a matcher for its region. But we're just using the roles of publisher and subscriber and matcher as kind of an abstraction to separate the roles that has to be fulfilled in the system, if that makes sense.
Yeah. Okay. So I mean, I think I was sort of going to follow up with that for a decentralized system then. So it means in a decentralizized version,
it should be much easier, actually, simpler than your current design.
Yeah.
It actually should be a lot more simpler. Okay. It's really about sending publish subscribe requests to the matcher / broker, right? And then do
in a centralized systems, you have one matcher basically. That's what you have in a centralized system. Only one matcher.
And if you design it right, the whole centralized is just sort of like a special instance of a distributed system where, as Herman said, there's just one matcher. Yeah. Right. So is that okay? Is that understood?
Yes.
Yeah. Okay. All right. Okay. So I have another feedback regarding the terminology. This is something I've been observing a while, but I think I'd like to bring up. Is we have used the terms AOI, or AOE, area of interest or area of effect in a sense. However, I am feeling this is sort of a personal feel. Okay, so would like Herman's feedback as well. because
Okay.
these terms originate actually from the virtual environments or
Yeah.
virtual worlds simulator research fields.
Okay.
They may not be as common or as understandable in other fields. Okay, like messaging systems or like the PubSub communities. So I am thinking about maybe we can consider to not use the AOI AOE terminology, and just because they are essentially just publication areas and subscription areas,
Subscription
right?
areas, yeah.
Right.
Yeah.
If you think about, I think that's essentially what it is. And
That's-
since we are using a PubSub paradigm now, and also borrowing the terminologies and the concepts and just extending a bit to the spatial domain, I would suggest that for us to simplify and just follow the terminologies in the
Okay.
PubSub world. I don't know if
Okay.
that makes sense. I mean, to
It
you
does.
guys.
It does.
And Herman, what do you think?
Well, when you mentioned it just now, the two words that popped in my head was publication area and subscription area. So
subscription
yes,
area.
I
Exactly.
agree. Yeah.
Right. So I
Exactly.
mean, and that's good too, because that means we are using a more general concept, right? That's sort of kind of understandable beyond just the virtual environment, virtual world
Yes,
community,
precisely. Yeah.
right? And I think it would help in that sense because essentially, the last jargon, the last terms, the last concepts, I mean, new concepts you have to introduce or ask your readers to know, to follow. The wider the readership. Okay.
Yes. Yeah.
I mean, there's this story. I don't know if you guys have heard of Stephen Hawking, right? The famous physicist. When he wrote his book, A Brief History of Time. Okay, that was like a famous book. His publisher told him, for every mathematical equation you put into the book, you will slash your sales volume by half. You get the point? Okay. So for every equation you introduce, the sales of your book will be half of that. So in the end, he put 0 equation into that book. It's all just description, all words. Okay, Stephen
Okay.
Hawking's. Okay. Okay, get that?
May you rest in peace.
Okay, so I guess what I'm suggesting is, try to reduce the number of terms and concepts that's required for our readers to understand about our design. Okay. And since we already introduced the PubSub concept to them and publication subscription areas, then I would suggest that's maybe just abolish the terms of AOI and AOE.
Okay.
And
Yeah, I think that's a good idea. Yeah.
Yeah, you see, so we can simplify our terms, retaining the same concepts, and maybe deliver more concisely. This is both from the paper writing and also the practical design level. Okay, because I see the message. Quite. All right, sorry, my daughter is asking. All right, so yeah, so I guess that's the main feedback, and I think for next step, what would be useful is I think it would still be useful for you to just revise and maybe summarize the centralized version, okay, into I think you can probably make it even a simpler version, okay, of the message and also of the procedure protocols, since now you understand the concepts better, right?
Yeah.
Okay.
Yeah.
But if possible, I would like to see you start to move to the decentralized version design now.
Yes.
Okay. Of both the protocol and also the procedures that's needed. And you can even combine the two if you like. The reason to create a centralized version is just for you to get the basics right. Okay, and make sure you understand them correctly. But if you design a decentralized version, essentially centralized version is just 1 matcher equals 1, right?
Yeah.
Yeah. So that's just a special case, and everything else should work. Should still work, right?
Okay.
Okay. Is that okay?
Yeah. Yeah, it is.
Okay. All right. All right. So Herman, what do you think?
Yeah.
Yeah, that sounds good.
I think Victor is I think can probably start to move to the decentralized version design.
Yes,
now.
definitely.
Yeah.
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 And we will check, whether it would still work, right? It should work
Yeah.
as a centralized design when matcher,
Yeah.
when there's just one matcher.
Yeah.
Okay.
Okay.
We'll do that.
All
Thank
right.
you very much.
So yeah, good. So I think we'll sync next Tuesday then. Okay.
Yes.
Well,
And
we'll
yeah.
well tomorrow morning at 8:30.
Oh yeah,
Or
sorry.
whatever your time.
Tomorrow,
Oh
yes.
yes, I was
yeah.
gonna ask
And
about that.
yeah, yes, the monthly mastermind, and it will be it will be about this time. Okay, so 24 hours from now. Okay.
Yes. Yeah.
Mastermind, yes.
Okay.
Thank you
All
very
right.
much.
Okay. So thanks, Herman and Victory. Okay, and look forward to tomorrow's the brain event, the mastermind.
Cool.
Okay. All right.
Thanks.
So see you tomorrow. Yeah. Yeah. Bye bye.
See you
Bye
tomorrow.
bye.
Bye.
Take care. Bye bye.